This is the OCR GCSE 9-1 Maths paper 4 from the higher tier, and it's from the June 2019 series, and this paper is a calculator paper. Question number 1, we have to calculate the cube root of 210 divided by 10 squared plus 5 squared, giving our answer correct to 3 significant figures. Well, if we work out the value of this on our calculator, if we key in the cube root of 210 over 10 squared plus 5 squared, what you'd find is we get a value of 1.18878439 and we need to round this to 3 significant figures. Well, if we take a look at the third figure, which is the 8, the figure after it, which is also 8, is 5 or greater, and therefore we round this 8 up to the next digit, and therefore the value of this is equal to 1.19, of course given to 3 significant figures. Question number 2. The ratio 50 grams to 1 kilogram can be written in the form 1 to n. We have to find the value of n. Well, over here you'll find we have grams here and we have kilograms here. And to convert from grams to kilograms, well, what we can do to convert kilograms to grams is multiply by 1,000, and to go from grams to kilograms, we can divide by 1,000. And therefore, what you'd find is 1 kilogram is the same as 1,000 grams. And with this, what we can do is express the ratio 50 grams to 1 kilogram as 50 grams to 1,000 grams. And the idea is over here, we need to simplify this in the form 1 to n. And to do this, well, to go from 50 to 1, we would have to divide by 50, and therefore 1,000 divided by 50, you'd find this to be 20. And therefore you can see the value of n is equal to 20. Question number 3. Anne, Barry and Colin share a prize in the ratio 3 to 4 to 5. Colin gives 1/3 of his share to charity. What fraction of the whole prize does Colin give to charity? Well, first of all, over here, you can see the fraction Colin has. Well, Colin's part is 5, so we have 5 over 3 plus 4 plus 5. So if we work this out, we have 5 over 12 as the fraction Colin has. And therefore, what happens is Colin gives 1/3 of his share to charity, so the fraction Colin gives to charity will be the 1/3. Okay, so we've got the 1/3 of this amount, so of course we multiply by 5 over 12. So if we work this out, indeed we end up with 5 over 36. So therefore, this is our answer, 5 over 36. And now for part B, Delia, Edwin and Freya share some money in the ratio 5 to 7 to 8. Freya's share is 1,600. How much money did they share? Well, here we have to find out the total amount of money they have. So far we've got this ratio of D to E to F equaling 5 to 7 to 8. And we know already Freya has 1600. So we have 1600 for Freya. And then you can see here 8 times by 200 gives the 1600. So we have to multiply each of these parts by 200. So we have 5 times by 200, which is 1000. 7 times by 200, which is 1400. And therefore, the total would be 1000 plus 1400 plus 1600, which is 4000. So therefore, they shared £4,000 between them. Question number 4. A bus timetable shows the following information. A bus following route T leaves for the train station every 20 minutes. A bus route following route A leaves the airport every 18 minutes. A bus following route T and a bus following route A both leave at 8:37 a.m. When is the next time one of each bus is timetabled to leave at the same time? Well, to do this, what we need to do is find the lowest common multiple of 20 and 18. And then that will allow us to find when they leave the bus station at the same time. So we need to find out the lowest common multiple of 20 and 18. So if we consider route T, you can see it leaves every 20 minutes. So we've got 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. I'm listing the multiples for route T. And if we list the multiples for route A, we have 18, then we have 36, then we have 54, and if I add 18 to this, we end up with 108, and then if I add 18, we have 126, adding on another 18, we have 144, add on another 18, we have 162, add on another 18, we end up with 180, another 18, we have 198, and another 18, we have 216. So we've got the multiples of 20 and 18 listed here, and therefore the lowest common multiple you can see is 180. So therefore, we have 8:37 a.m. plus 180 minutes. And what we need to recognize in this question, to go from minutes to hours, we divide by 60, and hours to minutes we times by 60. And therefore, if we divide 180 by 60, we have 8:37 a.m. plus another 3 hours. It turns out here they both leave at the same time next at 11:37 a.m. So we have 11:37 a.m. And now for part B, we have to write down one assumption that was necessary to solve the problem. Well, here we need to assume that there will be no delays. In other words, everything is sticking to schedule. Question number 5. Benny is 7 years older than Aisha. Chloe is twice as old as Benny. The sum of their 3 ages is 57. We have to work out the ages of Aisha, Benny, and Chloe. So what we can do over here is let Aisha's age equal x. So, letting Aisha's age equal x, you can see then if Benny is 7 years older than Aisha, then Benny's age is equal to x plus 7. And then Chloe is twice as old as Benny, so therefore Chloe's age is twice Benny's age, so we've got two lots of x plus 7. And the total of their three ages is equal to 57. So we have x for Aisha plus x plus 7 for Benny plus two lots of x plus 7 for Chloe. It turns out here we would get 57. So with this, what we can see then, we have x plus 2x, so that will be 4x. And then we have 7 plus 14, that's 21. So we've got 4x plus 21 equals 57. 4x, that's equal to 57 take away 21, which is 36. And therefore, x is equal to 9. 36 divided by 4 gives us 9. So therefore you can see, because we let Aisha's age equal x, her age is 9, Benny's age is 7 more than 9, so 7 plus 9, that's 16, and Chloe is twice the 16, which is 32. So here are their ages. Question number 6. 120 students in Year 10 and Year 11 sit a test, and 61 of the students are in Year 10, 83 of the students are right-handed, 20 of the students in Year 11 are left-handed, one of the students in Year 10 and one of the students in Year 11 are chosen at random. Which is more likely to be left-handed? Show you're working. You may use this table if you wish. Well, here we can use a two-way table. The reason for that, we've got two categories, Year 10 and Year 11 being one category, so year group being one category, and we've got another category either being left-handed or right-handed. So let's create a two-way table. We've got those in Year 10 and we've got those in Year 11. We've got those who are left-handed and we've got those who are right-handed. And what we can do here is find the totals. So we've got the total here for Year 10 and we've got the total here for Year 11, and here we've got the total for left hands, here we've got the total for right hands, and here we'd have the grand total, and the grand total will be 120. The reason for this is because there's 120 students in total. Now, 61 of the students are in Year 10, so a total of 61 students in Year 10. So that means we've got 61 here. 83 of the students are right-handed, so we've got 83 in total who are right-handed. So we've got 83 over here. And then we've got 20 students in Year 11 who are left-handed. So in Year 11, and those who are left-handed, we've got 20 over here. And now we can find out the missing values in this two-way table. First of all, what you can see is the total number of Year 11 students, that will be 120, take away 61, which is 59. So we have 59 here. And therefore, Year 11s who are right-handed would have 59, take away this 20, which is 39. And those who are in Year 10 and who are right-handed, we have 83, take away this 39, which is 44. And those in year 10 who are left-handed, we have 61 take away 44, which is 17. And the total of those who are left-handed will be 17 plus 20, which is 37. Now we're looking for the probability that we have a left-handed student given that we have year 10, or we're looking at the probability that we have a left-handed student in year 11. And comparing the probabilities will determine which year group is more likely to be left-handed. So, the probability that we are left-handed, given we are in year 10, left-handed in year 10, we've got 17 over 61. And if we work out the decimal equivalent, 17 divided by 61, you'd find this to be 0.2786, etc. And now if we take a look at the probability of being right-handed given we're in year 11, if we'll take a look at the probability that we are left-handed given we're in year 11, well, in year 11 we've got a total of 59, and of those who are left-handed is 20. So we've got 20 over 59. So 20 divided by 59, you'd find this to be 0.3389, etc. And therefore what you can see here, it's more likely that we're left-handed in year 11 because this probability is greater than this probability. So therefore we have year 11. Question number 7. The diagram shows a shape A, B, C, D, E. The shape is made from a rectangle, and that's what we see here. A right angle triangle, that's what we see here, and a quarter circle, that's what we see here. And F is the midpoint of BD, and AE is equal to 18 meters, and the perpendicular distance from C to AE is 41 meters. We have to work out the perimeter of the shape ABCDE. Well, what we need to do first of all is find out the missing lengths. If F is the midpoint of BD, then BF, that's equal to FD, and that's of course equal to 18 divided by 2, which is 9. So we have 9 meters here, and also here. And also, this length here is 9 meters, because we've got a quarter of a circle, the radius will be the same. So therefore, CF, that's also equal to 9 meters. And what we can now do is work out the length AB. AB is equal to 41, take away the 9. So AB, that's equal to 41 take away 9, which is 32 meters. So we've got 32 meters here. And now what we can do is find out the length of this arc, and we can do that by recognizing we've got a quarter of a circle. So CB, well, to work out the area of a to work out the circumference of a circle, that's pi times by 2 times by the radius. So we've got 2 times by pi times by the radius, which is 9, and then we divide this by 4 because we have a quarter circle. And therefore here what you can see is we have 9 pi over 2 meters for the length CB. So here we've got 9 pi over 2 meters for CB. We can find out what CD is using Pythagoras. CD That's equal to 9 squared plus 9 squared square rooted. So if we work this out, we've got 81 plus 81 square rooted, which is 9 times by the square root of 2. So we've got 9 root 2 meters over here. We now have enough information to work out the perimeter. So for the perimeter, we've got the 9 root 2 added to the 9 pi over 2. And then we have the 32 and the 18 and another 32 over here, because the opposite sides of a rectangle are equal. So we've got 32 plus 32, which is 64. So we've got 2 times by 32 plus the 18. So now if we work all of this out, we've got 9 root 2 plus 9 over 2 pi plus 2 times 32 plus 18. It turns out here we get 108.86, etc. And therefore, if we round this to 3 significant figures, we have 109 meters. Question number 8. Triangle A and triangle B are drawn on the grid. That's what we see here. And for part A, we have to describe fully the single transformation that maps triangle A onto triangle B. Well, if we match up the corresponding points together, for example this and this, and this and this, and then this and this, well, what you can hopefully see over here is we've got a centre of -1 across and 0 up, and hopefully you can see the shape has been rotated by 180 degrees, and this here is our centre. And therefore, when we come to describe the single transformation that maps A onto B, we would have a rotation, centre with coordinates -1, 0, and the angle is 180 degrees. And now for part B, we have to describe fully the single transformation that is equivalent to a reflection in the line x equals 3, followed by a translation by 4, 0. You may use the grid above to help you. Well, let us consider transforming triangle A to help us. So if we consider triangle A, well, first of all, we have a reflection in the line x equals 3. So if we carry out that reflection in the line x equals 3, well, you can see here we've got the line x equals 3. And then the shape we get from that will be the following. We have this shape over here. We'll call this A dash. And then after that, we have a translation by 4, 0. So let's deal with the translation by vector 4, 0. So at this point, we're going to move 1, 2, 3, 4 units to the right, and therefore the resulting shape is over here. We'll call this shape a double dash. And what we need to figure out is what is these two transformations the same as a single transformation. Well, hopefully you can see we'd have from A to A double dash some sort of a reflection. You can see they are mirror lines of each other, and we need to find out that mirror line essentially. This point and this point, they are 6 units away from each other, so half of the 6, that's 3. So if we go 3 units this way, that's the same as going from here to here by 3 units. And therefore, we've got a reflection in the line x equals 5. So, we have a reflection in the line x equals 5 being equivalent to these two transformations. Question number 9. The diagram shows triangle ABC, that's what we see here. CD is parallel to the line AB, and that's indicated by the arrows here. AC and E line a straight line, and the angles of size A, B and C are shown in this triangle, and we have to insert A degrees, B degrees or C degrees to make this statement true. Give a reason for your answer. Well, DCE, so we're looking at DCE. This over here is going to be the same as angle A. So this angle is the same as this angle, because hopefully you can see we've got corresponding angles. So here we've got A degrees because we have corresponding angles. And we have to use the diagram and the answer to part A to show that the angles of a triangle add up to 180. And we have to give a reason for each statement we make. Well, if we take a look at this diagram over here, you can see that BCD, this will equal the angle B over here, which is the same as this angle over here. And the reason for this is because we have alternate angles. So let's just write that. So rather we have alternate angles. And what you can see then is A plus B plus C is equal to 180. Question number 10. Claudia invests £25,000 at a rate of 2% per year compound interest. We have to calculate the total amount of interest she will have earned after 5 years. Give your answer correct to the nearest penny. Well, over here, we've got our original amount, 25,000, and because we are investing at a rate of 2% per year compound interest, we'd have to multiply by 1.02. So this over here refers to the rate of 2% per year compound interest, and we'd have to raise this to the power of 5. The reason for this is we're looking at how much interest she has after 5 years. So what we're finding here is the total amount of money she has after 5 years. So we've got 25,000 times by 1.02 to the power of 5, which is 27602.02. And therefore, for the interest will be the difference between this amount and this amount. So therefore, for the interest, we would have 27602.02 take away 25,000 100, rather 25,000. So if we do this value, take away the 25,000, it turns out here the interest we have is 2602.02. Of course, we need to make sure we give our answer to 2 decimal places. So therefore, to the nearest penny, we have 2602.02. Question number 11. The area of a rectangle is 56 meters squared, correct to the nearest meter squared. The length of the rectangle is 9.2 meters, correct to the nearest 0.1 meter. And we have to calculate the smallest possible width of the rectangle. Well, for this, we need to calculate the upper and lower bounds for the area and the length. That's because these values have been rounded to a certain degree of accuracy. So therefore, for the upper bound for the area, that will be 56.5 meters squared. And for the lower bound of the area, that's equal to 55.5 meters squared. And if we do the same thing with the length, the upper bound of the length, well, that will be, if we're rounding to the nearest 0.1 meter, this will be 9.25 meters, and the lower bound of the length, that will equal 9.15 meters. So how does this help us? Well, we want to calculate the smallest possible width of the rectangle. So to calculate the width, we do area divided by length. Now, because we are finding the smallest possible width, we need to find the lower bound of the width. So the lower bound of the width, that will equal, well, we want the value of this to be as small as possible, so we want the lower bound of the area divided by the upper bound of the length. And this value will give us the smallest possible value for the width. So, working all of this out, we've got the lower bound of the area being 55.5 meters squared, and the upper bound of the length, that's 9.25. So, if we work all of this out, we have 55.5 divided by 9.25, that's 6. So therefore the smallest possible width of the rectangle is 6 meters. Question number 12. Here are the first 4 terms of a sequence. We've got -1, 4, 9 and 14. We have to write an expression for the nth term of the sequence. Well, what we can do is find the difference between each of these. You can see the difference between each of these, that will be +5. So we have 5 for the difference between each of those. So we've got a 5n somewhere, and if we find out the 0th term, we'd have to do the opposite of +5, which is -5. And if we do -1 take away 5, that will be -6. And therefore, what we'd end up with is 5n minus 6 for the nth term of this sequence. And now for part B, the nth term of another sequence is given by an squared plus bn. The third term is 9 and the 6th term is 126. We have to find the value of A and the value of B. Well, if we consider the third term, well, this is when n is equal to 3. So this over here, if we work out the third term, that's when n equals 3. And when n equals 3, we have A lots of 3 squared plus B lots of 3. And we know that this is equal to 9. So we've got 9A plus 3B equals 9. And if we divide through by 3, what we'd find then is 3A plus B equals 3. Leaving it in this form makes it a bit easier to work with. And the 6th term is 126, so when n equals 6, we've got A lots of 6 squared plus B lots of 6 equals 126. So we've got 36A plus 6B equals 126. And if we divide these values by 6, 126 divided by 6, that's 21. And therefore, we've got 36A divided by 6, which is 6A. So we've got 6A plus B equals 21. We've got two equations, this equation and also this equation. We've got two unknowns, A and B. We can solve equation 1 and 2 simultaneously to find out A and B. And we can do this by subtracting the equations. So we will do equation 2, take away equation 1, the justification, we've got the same number of B's and we've got the same sign, both being plus. 6A take away 3A, that's 3A, and B take away B, that's 0B, 21 take away 3, that's 18. 3A is equal to 18, A is equal to 6, and when A is equal to 6, we can substitute into any equation, for example this one. So we've got 3 lots of 6, which is 18. So we've got 18 plus B equals 3, and if we subtract 18 from both sides, you can see that B is equal to negative 15, and therefore you can see A is equal to 6, B is equal to negative 15. Question number 13 for part A. The cumulative frequency graph shows the distribution of the heights of members of a rowing club. That's what we see here. And for part A and the first part, we have to find the median. Well, you can see over here there's 120 pieces of data. So for the median, what we'd have to do is n divided by 2. So we've got 120 divided by 2, which is 60. So we want the 60th value to help us find the median. So if we go across over here from 60 to the line, and then from here we'll go down to find out the corresponding value. So if we draw a line down from here, what you can see is the median is 172. For the next part, we have to find the interquartile range. Well, for the upper quartile, we've got over here 3/4 of 120, which is equal to 90. So for the 90th value, if we go up to 90, that is over here. And then if we draw a vertical line down from here, you can see then the upper quartile is a value of 176.5. So we've got 176.5 for the upper quartile. And for the lower quartile, if we do the same thing, we've got 1/4 of 120, which is 30. So with this we can find the lower quartile. So 30 values, and then going down from here, you can see then we've got the lower quartile being equal to 160. And therefore for the interquartile range, what we'd have is the interquartile range equaling the 176.5 take away the 160. So if we work out the difference between these, we end up with 16.5. So we've got 16.5 centimeters. And now we have to calculate the percentage of the members who are at least 180 centimeters tall. So what we do is we go and find the 180, which is over here. And if we draw a line up from 180, as we see here, and then if we draw a line across, that corresponds to a cumulative frequency of 100. So, what does this mean? Well, to work out the percentage of members who are at least 180 centimeters tall, well, this 100 means that 100 people have a height of 180 meters or less. So at least 180, well, if we work out this difference here, this corresponds to those who have a height of more than 180 centimeters. So we've got 20 people here. And therefore for the percentage, we'd have the 20 over the 120, and of course times this by 100. So it turns out here we've got 100 divided by 6, which is 16.6%, where the 6 here is recurring. So we've got 16.7% given to one decimal place. And now for part B, the histogram summarizes the heights of the 153 members of a swimming club, and which club has the greater median height. You must show your work. Now, what we can do first of all is find the frequencies for each of these intervals. And we can do that by recognizing with the histogram, frequency density multiplied by class width is equal to frequency. So here we've got a class width of 20, we've got a frequency density of 1.4. Multiplying those together, we get 28 as our frequency for this interval. For the next interval, we've got 10 as our class width. Our frequency density is 7.4. So here we get 74 as our frequency for this interval. Next, we've got a class width of 10. The frequency density is 3.6. And therefore here we get 36 as the frequency for this interval. And finally, we've got 20 times by 0.75, which is 15. So we've got 15 for this interval. How does this help us to find out what the median is? Well, if we form a quick table, we can use linear interpolation to find out what the median is. So we've got our different heights in intervals. We've got the frequencies being 28, 74, 36 and 15. And what we can now do is find the cumulative frequency. For the cumulative frequency, we begin with 28, then 28 plus 74, that's 102. 102 plus 36, that's 138. And adding 15 to this, we get 153. And that's in line with what was mentioned. We have 153 people in total. So now what we can do is use linear interpolation to find out where the median is. Well, if we've got 153 pieces of data, 153 divided by 2, that's 76.5. So let's write that down. 153 3 divided by 2 is 76.5, and the 76.5 value, that's in this interval here. So it's in the interval from 160 to 170. So now let's use linear interpolation. So if we use linear interpolation, let's just create a quick sketch. We've got the median over here with a value of 76.5. And well, what we can see then is the median is in between 160 and 170. So we've got 160 here, 170 over here. And what you can also see is there's 28 people with a height of 160 or less, and there's 102 people with a height of 170 or less. And if we consider the gradient of a straight line, we've got here m, take away 160 over 76.5, take 28. This is of course equal to 170 take 160 over 102 take 28. And our job is to find out what m is, the median. So to find out what m is, we've got this value being multiplied by 76.5 minus 28, and then we add on the 160. So this is what m is. So if we work all of this out, we have 170 minus 160 over 102 take away 28 multiplied by 76.5 take 28 plus 160. So it turns out here we get the median being approximately equal to 166.55 etc. centimeters. And if we go back to what the median was for the other one, we had 172, and therefore what we can conclude is the rowing club has a greater median. So the rowing club has a greater median. Question number 14. The graph shows the speed of a train during the first 60 seconds of motion, and for part A, what is the speed of the train after 9 seconds? Well, 9 seconds, if we draw a vertical line up at 9 seconds, which is over here, and then draw a line across to find out the corresponding speed, you can see the speed here is 12 meters per second. And for part B, what does the straight line suggest about the speed of the train over the first 15 seconds? Well, you can see here, we're starting off at 0, we've got a positive gradient, so therefore the gradient of a speed time graph represents the acceleration, and because we have a straight line, we can conclude acceleration is constant. Now for part C, we have to work out the average speed of the train in meters per second during the first 60 seconds. Well, for this, what we need is to find the distance. The total distance divided by the total time will give us the average speed over this entire period. So for the total distance, well, that's just the area of a trapezium. So we've got 1/2 times by the sum of the two parallel sides. Well, we've got 60. And then here we've got, well, we're going from 15 to 50. So that's a value of 35. And the height, that's 20. So we've got 10 multiplied by 95, which is 950. So we've got 950 meters that we travel in total, and therefore, for the average speed, we've got the distance, 950, divided by the 60 seconds. So therefore, working this out, 950 divided by 60, that's 15.8. So we've got 15.8 meters per second given to one decimal place. So we have 15.8 meters per second. Question number 15. The diagram shows a triangle OAB and the points C and D. The vector OA is equal to 3A, OB is 3B, and C lies on AB such that AC is equal to 2CB, and D is such that B to D is equal to 2A plus B. And we have to show using vectors that OCD is a straight line. Well, what we need to do is find out what OC is and OD is, and if OC is a multiple of OD, then we can conclude we've got a straight line. So if we find out what OC is, starting at O, finishing at C, well, for this, with this we've got AC equaling 2 times by CB, so the ratio of AC to CB is 2 to 1. So therefore, AC to CB is equal to 2 to 1. So AC is twice CB. Well, if we find out what AC is equal to, well, we're starting at A, finishing at C, so that's equal to A to O, and then from O to B. So we've got AO equaling minus 3A, and then OB, that's equal to 3B. And therefore, if we use this ratio, you can therefore see, rather here, AB, you can therefore see that AC, that's equal to 2/3 of AB. So we've got 2/3 of minus 3A plus 3B. Turns out here we get AC equaling minus 2A plus 2B. And now if we find out what OC is, OC starting at O, finishing at C, that's equal to OA plus AC. So we've got OA equaling 3A, and then we add on minus 2A plus 2B, and this is equal to A plus 2B. So that's what OC is. And now we can find out what OD is. Well, we know already that B to D, this over here, is given by 2A plus B. And what we can find out is what the vector OD is. The vector OD, that's equal to O to B plus B to D. So OB, that's equal to 3B, and BD, that's 2A plus B. So here we get 2A plus 4B. And therefore, what you can see if we compare these, you can see that OD is equal to twice OC. In other words, multiplying OC by 2, we get this. And therefore, what we can conclude is OCD is a straight line. Question number 16. The table shows values of x and y. So that's what we see in this table, and for part A we have to show that these values fit the relationship that y is inversely proportional to the square root of x. So we've got y being inversely proportional, so we've got 1 over square root of x, and therefore y is equal to k over square root x. And therefore the value of k can be determined by multiplying y by the square root of x. Now, with x equaling 4 and y equaling 6, we can find out the corresponding value of k. K is equal to 6 times by square root of 4, so we've got 6 times by 2, which is 12. And when x is equal to 16 and y is equal to 3, k is equal to 3 times by square root of 16, so we've got 3 times by 4, which is 12. And when x is equal to 36 and y equals 2, we've got k equaling 2 times by square root of 36. So we've got 2 times by 6, which is 12. And therefore what we can see then is from here, y is equal to 12 over square root of x. And now for part B, a is inversely proportional to b squared, so we've got a being inversely proportional to b squared, and we're given that a equals 3.75 and b equals 4. We have to find a formula linking a and b. Well, from here, you can see a equals some constant a over b squared, and when a equals 3.75, b is equal to 4. So we've got 3.75 equals a over 4 squared, and therefore a is equal to 3.75 times 4 squared. If we work this out, we get 60, and therefore our formula is a equals 60 over b squared. Question number 17, we have to show that a cubed to the power of minus 1/3 times a squared to the power of a half equals 1. Well, here, first of all, we can simplify this and this using the law of indices. X to the power of m to the power of n is the same as x to the power of mn. And so therefore, when we have a base to a power to another power, according to this rule, we multiply the powers. So we've got a to the power of 3 times by minus 1/3, and then we multiply this by, here we'd have a to the power of 2 times by 1/2, and if we tidy this up, we'd have a to the power of minus 1 times by a to the power of 1. We've got another rule of indices, we've got the same base, and then we are timesing, we add the powers. So x to the power of m times by x to the power of n is the same as x to the power of mn. So what we have here then is a to the power of minus 1 plus 1, which is just a to the power of 0, and of course a to the power of 0 is just 1. And so therefore this result is equal to 1. Question number 18. Region R satisfies these inequalities that we see here. We've got y being greater than 3, y being greater or equal to x, and x plus y being less than or equal to 9. And by drawing 3 straight lines on a grid, we have to find and label the region R. Well, if we deal with y being greater than 3, well, because we've got a strong inequality symbol, we'd have to use a dashed line. And of course, temporarily, if we have y equals 3, we draw the line y equals 3, but with a dashed line. So here we've got, if I draw it with a pen, we've got over here that inequality. And what we can do is determine which side we can shade, and we shade in the region we don't want. So if we pick the origin as a testing point, well, here we've got y being 0. Is this greater than 3? Well, no, it isn't. So we don't want everywhere below this line here. So we shade under the line over here. Okay. Next, if we deal with y being greater or equal to x, well, we'd have to use a solid line because we've got a weak inequality symbol. And if we draw the line y equals x, that looks something like this. Let's just draw it on. Question 19, we have to solve this equation algebraically, giving our answer to 2 decimal places. So what we can do over here is substitute into the quadratic formula. So here is a reminder of what the quadratic formula is. And if we label our values of a, b, and c, you'd find a to equal 3, b to equal 8, and c to equal -5. So if we substitute into the quadratic formula, we have x equals, let's draw a line here, minus b, so we've got -8 plus minus 8 squared minus 4 times 3 times -5, square rooted, and then we divide by 2 lots of 3. So if we work this out, we can just use our calculator, substituting it in. If you've got a Classy or ClassWiz, we can just use the equation solver. So we've got 3x squared plus 8x minus 5. We end up with x equaling this or this, which as a decimal equivalent, we've got -3.189, etc. And we also have 0.522, etc. So therefore, to 2 decimal places, we have x equals 0.52 or x equals -3.19, given to 2 decimal places.